Hello friends, welcome to our channel. I hope you are all in a very good health and studying well with your full focus. Thank you for joining me. Today we are going to solve some questions from the examples which are given before the exercise. Let us work out 5.3. So our topic is ratio and proportion, and name of the book Ganit Prakash class 10. Let us take some important questions from examples. So this is our question. Now let us use the given relation. Now let us multiply the numerator and the denominator by c, and let us multiply the numerator and denominator of the second ratio by b, and let us multiply the numerator and denominator of the third ratio by a. So it gives us Now we can see that if we add the numerators by addendo, then bcx minus bcx and plus bcx minus abz and plus abz minus acy and plus acy will be cancelled. So the numerator will become 0. So by applying addendo, we can write the numerators get added and the denominators get added, forming a new ratio. So the numerator becomes 0. That means this ratio becomes 0. So we can say these three ratios are equal to 0. Now if we compare each ratio to 0, we get now we can write x by a equal to y by b. Now again if we equate this ratio to 0, we get when the second ratio is compared to 0, we get so from these two relations we can write therefore x by a equal to y by b is equal to z by c. So this is what we needed to prove. Now let us proceed to next example. Now let us multiply minus a to the numerator and the denominator of the first ratio. So it becomes this, and let us multiply the numerator and the denominator of the second ratio by b, and let us multiply the numerator and the denominator of the third ratio by c. So the ratios become now if we apply addendo by applying addendo we can get a new ratio which will be equal to the previous ratios, and the numerator of the new ratio will be minus abz minus acy plus bcx plus abz plus acy plus bcx minus a square plus b square plus c square. Now plus abz and minus abz will be cancelled, plus acy and minus acy will be cancelled, so we are left with 2bcx by b square plus c square minus a square. Again we are using the given information. So this is what we are getting. Now if we multiply the numerator and denominator of the first ratio by a, now we are using plus a not minus a. Okay, so we are multiplying it by plus a, and similarly the denominator will also get multiplied to plus a. Now we are multiplying the second ratio by the numerator, and the denominator gets multiplied by minus b, and Let us multiply the third ratio, the numerator of the third ratio by C and the denominator of the third ratio by C. So this is what we are getting. Now it gives us now by applying addendo, we get a new ratio which is ABZ plus ACY minus BCX minus ABZ plus ACY plus BCX. So plus BCX and minus BCX get cancelled, plus ABZ and minus ABZ get cancelled. So we are getting we are getting 2 ACY by A square plus C square minus B square. Our given ratio was BZ plus CY by A is equal to CX plus AZ by B equal to AY plus BX by C. Okay, it was given in the question. Okay, so when we multiply numerators and denominators by the same thing, the main ratio remains unchanged. Okay, without changing the main ratio, the main relation, we can multiply the numerator and the denominator of each ratio by something. So when we modify the given relation, the relation remains unchanged. Okay, so when we modify it, the main relation remains unchanged. So firstly, we can see these three ratios are modified and we are getting a new ratio which is equal to the previous ratios. So we can say this ratio is equal to the given ratios. Okay, and again by using the given ratio, so this is our given ratio. Okay, this is our step 1. Okay, this is our step 1. And this is our step 2. This is our given ratio, and when we multiply the numerator and the denominator of each ratio by something equal, the main ratio remains unchanged. So we are making some modifications and applying addendo, so we are getting this ratio, which is also equal to the given ratio. Okay, this ratio is equal to the given ratio. Similarly, in step 3, we can show each ratio, that means is equal to 2abz by a square plus b square minus c square. Okay, so now we can see that the given ratios are equal to this ratio and this ratio. So we can say, therefore we can say these three ratios are actually equal. Now if we divide each ratio by 2 ABC, we get this. So this is what we needed to prove, where we are provided with a relation and we need to prove A equal to B equal to C. So let us start it. Let us write the given relation. So we can perform same operation to each ratio. So let us subtract each ratio from 1. We are subtracting each ratio from 1. Now so the ratios become so we are getting now if we add 1 to each of these ratios, Now we can cancel a plus b plus c from the numerators. Now we invert all these ratios. If we invert all these ratios, we are getting, or we can say, a equal to b equal to c. So this is what we needed to prove. So I hope it is clear to you. Now let us proceed to our next question. So this is what our question says. So let us first write the given information. Now we can say that these ratios are equal to k. Let therefore, if we compare these two things, we can say x equal to k into y plus z, and if we compare these two things, we can say y is equal to k into z plus x, and if we compare these two things, we can say z is equal to k into x plus y. Now if we add these three equations, we get so we can take k common. So this is 2x plus 2y plus 2z. Now we can take 2 common. x plus y plus z cannot be cancelled from both sides of the equation, because x plus y plus z, we are not sure whether it is a non-zero quantity or not. It can be equal to 0. Okay, so we cannot cancel it. Only two non-zero quantities can be cancelled from both sides of the equation. So we do not know the value of x plus y plus z, so we cannot cancel it. So let us take it to the left side. Now if we take x plus y plus z common, now we can say when when the product of two quantities is 0, then we can say either of them should be equal to 0. Therefore, either x plus y plus z is equal to 0, or 1 minus 2k is equal to 0. That means k is equal to half. So we can see from this equation we can write x plus y plus z equal to 0 or k equal to half. So when k equal to half, we can say that each ratio should be equal to half. X is equal to minus y plus z. So if we put this into this ratio, so if we put the value of x in this place, we are getting x is minus y plus z by y plus z. So it becomes equal to minus 1. This is equal to minus 1. So from here we can say that each ratio is equal to minus 1. So each ratio is equal to half or minus 1. Thank you friends for today. Tomorrow we shall come with a new video where we shall be discussing some more examples, and after that we are going to start exercise 5.3 of ratio proportion. Thank you.